Good evening, everyone. Myself, Anjali Ramashankar Prasad. I am a PMRF scholar at IIT ISM Dhanbad. Today, we are going to start with Week 5 assignment session, Problem Solving, on Numerical Methods, NOC 23, MA 94. It is taught by Professor Amir Kumar Naik and Professor Sanjeev Kumar from IIT Roorkee. So, we will just wait for 2 minutes so that others will join, and then we will start with the session. So let's start. So here is your first question. So first question is, using Lagrange's interpolation formula, compute f of 4 from the given data set. So you have been given a data set where at points at x is equals to 2, 3, 5, 8 and 12, you have given the function value, f of x value. So at x equals to 2, f of 2 is equals 10. Similarly, at x equals 3, f of 3 is equals 15. Similarly, at x equals 5, f of 5 is equals 25. Okay. So in this manner, you have been given the data set. Now you have to compute the value at x equals 4. So you have to find the function value at x equals 4. Okay. So interpolate the value at x equals to 4 using Lagrange's interpolation formula. Okay. So find out what is the value of f of 4. Is it 20 or 20.8 or 19.7 or 21.0? Just use Lagrange's interpolation formula and compute the value at x equals 4. While substituting the values in Lagrange's interpolation formula at x equals at the place of x, simply put 4. So you will get the formula. If you have doubt regarding the formula, tell me. So what is the answer you are getting? So at x equals 4, the function value will be 20. Are you getting it? So how to proceed? Here, just first arrange the values as x0, x1, x2. So here x0 is 2, x1 is 3, x2 is 5, x4 is x3 is 8, x4 is 12. Okay. So corresponding to that, yes, what's the doubt? Is there any doubt? Okay. So at x0 is equals to f of x0 is 10. Similarly, f of x1 is 15, f of x2 is 25, f of x3 is 40, and f of x4 is 60. Now, let's see the Lagrange's interpolation formula. So, interpolation, what do you exactly mean with interpolation? So, using the given data, we can interpolate the value of f at any x in between these data set. Okay, that will be interpolation. Okay, so now for f of x is equals, so Lagrange's interpolation formula is f of x is equals x minus x1, x minus x2 into x minus x3 into x minus x4 upon, now in the first term you just eliminate the first term, first element, that is x naught. So you got this. Now at the place of x, just put x naught. So x naught minus x1 into x naught minus x2 into x naught minus x3 into x naught minus x4 into f of x naught. Okay, so this will give you the first term. Now second term is what? In the second term, remove x1. So you will get x minus x1, x naught, then x minus x2, then x minus x3 into x minus x4. Now, as you have removed x1, just put x1 at the place of x. So you will get x1 minus x naught into x1 minus x2 into x1 minus x3 into x1 minus x4 whole into f of x1. Similarly for x2, x3 and x4. Okay. So just substitute the values. You have x0, x1, x2, x3 and x4. Corresponding to that you have f of x0, f of x1, f of x2, f of x3 and f of x4. Okay. So substitute those values, and also you know the x value at which you have to interpolate. Okay. So you have to put 4 in place of x. So everywhere you are seeing here x in the numerator, just replace it with 4. Okay, and solve it. See what you are getting. Are you getting 20? If you have any doubt, you can unmute yourself and tell me. Otherwise, write in the chat box. Have you got it? Substitute the values of x, x1, x0, x2, x3, x4 and corresponding function values at those points. Are you getting it? 20, f of 4 is equals 20. Is there any doubt in this question, or shall we move to the next question? If it is clear. So are you getting f of 4 is equals 20? I hope it's clear. So let's move to the next question. So question number 2 is, using Newton's divided difference formula, compute f of 8 from the given data set. So you have given the data set, you have to calculate the value of f of x at x is equals to 8. Okay. So you have been given the value of f of x at x is equals 4, 5, 7, 10, 11 and 13. Okay. Now here you can notice that the difference between the consecutive elements is not equal. Here the difference is 1, here the difference is 2, here the difference is 3, here difference is 1, here difference is 3 again, 2. Okay. So you can see in the previous lectures that we did that Newton's backward interpolation formula or Newton's forward interpolation formula, in those things the difference between the consecutive elements were equal. Now in Newton's divided difference formula, it may be that the difference between the consecutive terms is not equal. Okay. So in such situations we use Newton's divided difference formula or other difference formulas. Okay. So using this data set, you have to compute the value of f of x at x is equals to 8. So find it as, is it 448 or 492 or 532 or 579? So please calculate it and tell me what is the value of f of x using Newton's divided difference formula. Just substitute the values of the data set into your Newton's divided difference formula. First calculate the difference table where x naught will be 4, x1 will be 5, x2 will be 7, x3 will be 10, x4 will be 11 and x5 will be 13. Corresponding to that you will get f of x naught, f of x1, f of x2, f of x3, f of x4 and f of x5. So compute it. Is there any doubt regarding the formula? Just substitute the values and we'll get the value at f of x. So what will you get? The correct answer is option A. Okay. So you will get f of 8 is equals to 448. So for that, first find out the divided difference table. Okay. For that, arrange the values of x in the column and second column will be f of x values corresponding to those x values. Okay. Now first calculate the first divided difference. So first divided difference, how will you get? Just simply subtract. In the numerator write 100 minus 48 and in the denominator it will be 5 minus 4, right? That is f of x naught x1. So this will give you first divided difference. So 100 minus 48 it will be 52 divided by 1, right? So you'll get first divided difference as 52. Similarly, second divided difference, how will you get 97? So just subtract 294 minus 100 and divide it by 7 minus 5, that is 2. Okay, so you will get 97. See, calculate it. Are you getting it? 97. Similarly, for the third term, for the third element, just subtract 294 from 900 and divide it by 10 minus 7, that is 3. So you'll get 202. Then for the next divided difference, just subtract 1210 minus 900 and divide it by 11 minus 10, that is 1. So you'll get 310. Similarly for last one, 2028 minus 1210 upon 13 minus 11. So you'll get 409. Fine. Now to calculate second divided difference, you will take the elements in the first divided difference column. Okay. So here I will get 15. Just subtract 52 from 97. That is 97 minus 52. Divide by. Now these two terms correspond to this 4, 5 and 7. Okay. So for second divided difference, you have to subtract 7 minus 4. Okay. So you'll get 15. So 97 minus 52 upon 7 minus 4. This will give you 15. Okay. Similarly for 21, what will you do? Subtract these two terms, that is 202 minus 97, divide it by, now this you will be getting from these three terms 5, 7 and 10. So divide by 10 minus 5. Okay. So you'll get 97. Sorry, 21. Now similarly for 27, what will you do? 310 minus 202 divide by 11 minus 7. Okay. So this will give you 27. Similarly for 33, how will you get it? 409 minus 310 divided by 13 minus 10. Okay. So this will give you 33. Fine. So in this way you will get second divided difference column. See, are you getting till here? Or if you have any doubt, tell me. If it is clear, then similarly you can do for the third divided difference. So third divided difference, how will you get it? So use the second divided difference column, that is 21 minus 15, and now these two terms are coming from C. You just go down in this way. So you'll get it from 10 and here it is from 4. Okay, 4, 5, 7 and 10. So it will be 21 minus 15 upon 10 minus 4. So you'll get 6 by 6, that is 1. Okay. Now next term, 27 minus 21, and this we are getting from 5, 7, 10 and 11. So 27 minus 21 upon 11 minus 5. Again it's coming 6 by 6. So it will give you 1. Okay. Now for the next term, 33 minus 27 divide by, this is coming from 7, 10, 11 and 13. So 33 minus 27 divide by 13 minus 7. So this will give you 1 again. Fine. So in this way you will get your third divided difference column. Now let's move to the fourth divided difference column. So here in the numerator you will do 1 minus 1 and in the denominator it will be, now this is coming from 4, 5, 7, 10 and see, just go downwards from this way, so you will get 11. Okay. So 11 minus 4. Now in the numerator as it is 1 minus 1, so you will ultimately get 0. So for the second term again 1 minus 1 in the numerator and in the denominator it will be 13 minus 5. So it will give you 0. Fine. Now fifth divided difference will be again 0. Okay. So in this way you will get. Now you have to calculate the value of f of 8. Okay, that is at x is equals to 8. So the write the Newton's divided difference formula and simply at the place of x just put 8. Okay. So you'll get these terms. What is Newton's divided difference formula says? F of x is equals your y naught plus then x minus x naught into f of x naught x1, that is first divided difference. So that is 52 plus x minus x naught into x minus x1. So here x naught is 4 and x1 is 5 and x, that is our 8. Now multiply it with second divided difference element, that is 15. So here it comes 15. Okay. Now next term again it comes x minus x naught into x minus x1 into x minus x2. So it is 8 minus 4 into 8 minus 5 into 8 minus 7. Now third divided difference that is 1. multiply it with that. Now just simplify it, you will get 448. Just see, are you getting it? Okay. So is it clear? Shall we move to the next question? So let's move to the next question. Question number 3 is, find the interpolating polynomial using Newton's divided difference formula from the following data set. Okay, so in the previous question, you had to interpolate at a particular point, interpolate the value of the function at a particular point. Now you have to calculate, you have to find the interpolating polynomial. Okay, so you have been given x at minus 4, f of x at minus x is equals minus 4, minus 1, 0, 2 and 5. So corresponding f of x values are also given. Now using this data set, just interpolate the polynomial using Newton's divided difference formula. Okay, it's similar to the previous question, just at the place of x we substituted there 8. Now here we have to just keep it as it is and simplify it. You will get the polynomial. So what is the polynomial you are getting? Is it A, B, C or D? So first you have to calculate the divided difference table as we did in the previous question. Fine. So here also just arrange all the data points. So first column will include all the x values, that is minus 4, minus 1, 0, 2 and 5. Okay. Now second column will be function value at those point x. Okay. So now at x is equals minus 4 you are getting 1, 2, 4, 5, at minus 1 you are getting 33, at 0 you are getting 5, at 2 it's 9 and it's at 5 it is 1, 3, 3, 5. Now calculate the first divided difference column. So for that, as we did in the previous case, just follow those steps. For the first, what we'll do, 33 minus 1, 2, 4, 5 and divide by minus 1 minus of minus 4. Okay. So this will give you the first element in the first divided difference column, that is minus 404. See, are you getting it? If you have any doubt, tell me. So first element you'll get from these 2 points. Then second, minus 28. How will you get it? 5 minus 33 divided by 0 minus minus 1. You'll get minus 28. Similarly, how will you get 2? 9 minus 5 divided by 2 minus 0. Okay. So you'll get 2. That is 4 by 2. That is 2. Now next term, how will you get it? So 1335 minus 9 divided by 5 minus 2. So you'll get 442. Okay. So this is how you will get the first divided difference column. Similarly, now calculate the second divided difference column. How will you get it? So for that you use these two elements, minus 404 and minus 28. So here it will be minus 28 minus 404 divided by minus 1 of minus 4. Okay, calculate it. Sorry, 0 minus minus 4. So you'll get 94. Similarly for 10, how will you get it? 2 minus minus 28 and divide by 2 minus minus 1. So for this 10, you will use 2 and minus 1. Similarly for 88, you will use 5 and 0. So just calculate the first divided difference column, second divided difference column, third divided difference column and fourth divided difference column. And check your values. Is it correct? If you have doubt in any of the steps, tell me. In calculating either first divided difference column, second divided difference column, third or fourth. Okay. So for the fourth divided difference column, how will you proceed? Similarly, 13 minus of 14 and divide by, this corresponds to these values, x equals minus 4 and 5. Okay, so 5 minus minus 4. So we'll get it 3. Is it clear? So after getting the divided difference table, apply Newton's divided difference formula. What is the formula? F of x is equals, first term is f of x naught plus x minus x naught into first divided difference, that is f of x naught x1 plus, this will be your first divided difference. Okay, minus 404 plus x minus x naught into x minus x1 into second divided difference, that is 94. Now how will you get it? From f of x naught, x1 and x2. So this is your second divided difference plus x minus x naught into x minus x1 into x minus x2 into x minus x3 into f of, here you will get third divided difference, that is x naught, x1, x2 and x3 plus x minus x naught into x minus x1 into x minus x2 into x minus x3 into x minus x4. Okay, so into f of x naught, x1, x2, x3, x4, that is your fourth divided difference. Fine. Now substitute the values of x naught, x1, x2, x3 and x4 in these and the corresponding divided differences. That is, this is first divided difference, that is minus 404. Then this is second divided difference, that is 94. Now this is third divided difference, that is minus 14. And this is fourth divided difference, that is 3. Substitute these values. So we'll get this equation and simplify it. See, are you getting option C, that is the polynomial as 5 minus 14x plus 6x square minus 5x cube plus 3x4. Simplify it. If you have any doubt, in the simplification or any of the steps? So tell me. If you have doubt in any of the steps, tell me. Or if it is clear, let me know. So we will proceed to the next question. Is it clear? So shall we move to the next question? So next question is question number 4. It says that find the missing term from the table using Newton's divided difference interpolation. So you have to use the Newton's divided difference interpolation and calculate the missing term over here. So you have been given the data points at x is equals 1, 2, 4, 5 and 6. So at x equals 1, y value is 14, at x equals 2, y value is 15, at x equals 4, y is 5, at x equals 6, y is 9. Okay. So you have to calculate the value of y at x is equals 5. So again you have to follow the same process. Just think that this point is not there. Okay. So you have all the given points are x naught, that is 1, x naught, x1 is 2, x3, sorry, x naught is 1, x1 is 2, x2 is 4 and x3 is 6. Okay. So use this 4 points and interpolate at x is equals 5. Okay. Since here we don't have to think about the difference between the consecutive terms, so you can go in this way. Okay. So calculate the value of y at x is equals 5. Is it 4.5? Is it 4, 3.5 or 3? Just apply the Newton's divided difference formula as we did in the previous questions. Here you have 4 data points and you have to interpolate the value of y at x is equals 5. Solve it and tell me the answer. So what are you getting the value of y at x equals 5? Anyone? So the answer is 3. Okay. Correct option is 3. So at x is equal to 5, y will be 3. How will we get it? So first construct the Newton's divided difference table from the known data points. So here we know only 4 data points, that is x naught is equals 1, x1 equals 2, x3 equals x naught equals 1, x1 equals 2, x2 equals 4 and x3 equals 6. Okay, so just arrange those points and corresponding to that write the function values, that is y values. So at x is equals 1, y is 14, at x equals 2 it is 15, at 4 it is 5 and at 6 it is 9. Okay, so now calculate the first divided difference. For that, how will you calculate? Simply, in the numerator it will be 15 minus 14 divide by 2 minus 1, right? So it will give you 1 again. Now, calculate the second element of the first divided difference column. So how will you get it? 5 minus 15 upon 4 minus 2. Okay. So this will be minus 10 by 2. It will give you minus 5. Now similarly for the third element, how will you get it? Just write 9 minus 5 in the numerator and in the denominator it will be 6 minus 4. So you will get 2. See, are you getting the first divided difference column? If you have got the first divided difference column, proceed for the second divided difference column. Okay. Now for the second divided difference column, how will you get it? Simply subtract 1 from minus 5, that is minus 5 minus 1 in the numerator and in the denominator it will be 4 minus 1. Okay. Since it corresponds to this x naught and x2 value. Okay. So you will get minus 2. Now for the second term, how will you get it? 2 minus minus 5 and in the denominator it will be, this corresponds to two values, x is equals to 2 and x is equals to 6. So it will be 2 minus minus 5 divided by 6 minus 2. Okay. So this will give you 7 upon 4. Now proceed for the third divided difference column. So for that you will do what? 7 by 4 minus minus 2 in the numerator and in the denominator it will be 6 minus 1. Okay, since it corresponds to this values, x is equal to 1 and x is equal to 6. So you will get it as 3 by 4. Okay, now as you have got the values in the first, second and third divided difference columns, now substitute those values in the Newton's divided difference formula. So what does it state? So Newton's divided difference formula is y of x is equals y naught plus x minus x naught into the first divided difference value, that is 1, plus x minus x naught, that is 1, into x minus x1, that is 2, into second divided difference value, that is minus 2, plus x minus x1 into x minus x2 into x minus x4. Okay, into the third divided difference value, that is 3 by 4. Just simplify it and at the place of x you will put 5, since you have to calculate the value of y at x is equals to 5. Okay, so substitute it over at the place of x. Just substitute 5 and see, are you getting y of 5 is equals 3? Is it clear now how you are getting y of 5 is equals to 3? If you have any doubt, tell me. Just follow the procedure, find the divided difference table and substitute the values in the Newton divided difference formula. And if you have given to interpolate at a particular point, so just substitute that point in the formula and you will get the value. Just see, are you getting option D, that is y is equals 3? If you have any doubt, tell me. Do you have any doubt in any of the steps? Or if it is clear, so shall we move to the next question? So the next question is, given the following values of f of x and f dash x, so here you have been given the data points at x is equals to -1, 0 and 1, and corresponding to that you have given the function value at x, that is f of x, and its derivative, that is f dash of x. Okay, so which of the following polynomial can interpolate the above data? So you have to found that which of these polynomials, either a, b, c or d, which of these polynomials can interpolate these data, that is x, f of x, and the corresponding f dash x. Okay, so which, for first of all tell me which formula will you apply so that you will get the polynomial interpolating
Ha-
this data?
Hermite interpolation.
Yes. So just apply the Hermite interpolation and
Yes. Fast is better.
So solve it and tell me which option is correct.
If option A is correct, I have solved.
Okay. So here you have to use the Hermite interpolation formula. So what is the Hermite interpolation formula? It is f of x is equals summation I equals 0 to 2. Since you have 3 points, so I will be x naught will, that is x naught, x1 and x2. So let it be I is equals to 0 at I equals to 1 and I at I equals to 2. Okay. So from I equals 0 to 2, summation from I equals to 0 to 2, that is 1 minus 2 into Li dash of xi into x minus xi into Li square of x into f of xi plus summation I equals 0 to 2 in of x minus xi into Li square of x into f dash of xi. Okay. So here what is L naught x, that is Lix, that is the terms in the Lagrange's interpolation. So L naught x is given by x minus x1 into x minus x2 upon x naught minus x1 into x naught minus x2. Here in the numerator we will exclude x naught term, and in the place of x we will write x naught in the denominator. Okay. So you'll get this. Now you know the x1, x2 and x naught values, that is minus 1, 0 and 1. So substitute those values, you will get x into x minus 1 by 2. Okay. So this will give you L naught of x. So when we get L naught x, you can simply calculate the L naught dash x. So find the first derivative of this term. So you'll get, first term will be x square by 2. So you'll get x minus x by 2. The derivative of x by 2 is minus 1 by 2. So L naught dash x is x minus half. Check, are you getting it? The first terms L naught x and L naught dash x. Now similarly find L1 of x, that is x minus x naught into x minus x2 upon x1 minus x naught into x1 minus x2. Okay. So substitute the values of x naught, x1 and x2. You will get 1 minus x square. Fine. Now when you will get L1 of x, you can calculate the L1 dash x. So here it will be, the derivative of 1 minus x square is, this term will be 0 and this will give you minus 2x, right? Now similarly calculate L2x and L2 dash x. Are you getting it? So once you have got all the values L naught x, L1 x, L2 x and L naught dash, L1 dash and L2 dash, substitute these values in this Hermite interpolation formula and simplify it. So you will get f of x approximately equal to 2x to the power 4 minus x square plus x plus 1. Okay. So option A is correct. Check, are you getting option A, everyone? Do you have any doubt in the Hermite interpolation formula? I hope it is clear to everyone. So let's move to the next question. So question number 6 is, let f of x be a function such that f of 30 is equals to minus 30, f of 34 is equals to minus 13, f of 38 is equals to 3, and f of 42 is equals to 18. Okay, so these are the data points we have been given. Now the question is, the root of the function f of x is equal to 0 using Lagrange's interpolation formula is. So you have to calculate the root of the equation, the root of the function f of x is equal to 0 using Lagrange interpolation formula. So here, as you have been given f of x is equal to 0, that is y is equal to 0. You have been given y is equal to 0. You have to calculate the value of x at which y is equals 0. That is the root of the function. Okay. So simply use the Lagrange's interpolation and swap the position of x and y in the Lagrange's interpolation. Okay. So normally we write y is equals to x minus x naught, x minus x1 and all those terms. So here, as you have to find x, so write x is equals to then y minus y1, y minus y2 in that way. Okay. So just switch the positions of x and y in the Lagrange's interpolation formula and you will get the root of the function f of x is equals to 0. Try it and tell me what's the root of the function. Is it 36.54, 36.98, 37.12 or 37.23?
37.23.
Okay. Others also try and tell me what's the answer. So here x naught is 30, right? X naught is 30, x1 is 34, x2 is 38, x3 is 42. Fine. And corresponding to that, f of x naught, that is f of 30 is minus 30. So y naught is equals to minus 30. Similarly, y1 will be minus 13, y2 will be 3, and y3 will be 18. Okay. So for the x naught, x1, x2, x3, you have got the corresponding y values, that is y naught, y1, y2 and y3. Okay. So now here it is required to find x corresponding to y equal to 0. You have to calculate the root of the function, that is x corresponding to y equal to 0. So Lagrange's interpolation formula will be x is equals, since you have to calculate x value, so keep it on the LHS, and here we used to use x, so replace it with y. So you will get y minus y1 into y minus y2 into y minus y3, since we have the values up till y3, divide by y naught, since here we have removed the y naught term, y naught value. So just replace y with y naught. So you'll get y naught minus y1 into y naught minus y2 into y naught minus y3 into here it will be x naught. Okay. Similarly for the second term, plus y minus y naught, here we will remove y1, so you will get y minus y naught into y minus y2 into y minus y3 divide by, at the place of y we will put y1, so you'll get y1 minus y naught, y1 minus y2, y1 minus y3, and since it's the second term, here we will multiply it with x1. Now plus the next term. Similarly, here we'll remove y2 and replace the terms in the denominator, where at the place of y we will write y2. Okay. Similarly, the fourth term, that is y minus y naught into y minus y1 into, here it will be y minus y2. Okay. And we are removing y3 term. So just replace in the denominator at the place of y, put y3. So you'll get y3 minus y naught into y3 minus y1 into y3 minus y2. Here it will be y2. Okay. And multiply it with x3. So you have all the values x naught, x1, x2, x3, and y naught, y1, y2, y3, and also you know the value of y, that is 0. So substitute all these values and calculate what you are getting the value of x, that is the root of the function. So after substituting, we will get x is equals 37.23, that is option D. Okay. So I hope all of you got it. So let's move to the next question. So question number 7 is, the following data set is given by, you have been given a data set and the values of x, the values of f of x at x is equals 1, 1.25, 1.5, 1.75 and 2. Okay. Now you have to calculate the value of f of 1.55 using Gauss forward difference formula. So use the Gauss forward difference formula and calculate the value of f of 1.55. So is it 0.4382, 0.4594, 0.4865 or 0.5178? Tell me what you are getting.
0.4382.
Okay. Others, please try it. Are you getting it 0.4382?
Yes.
So here first let's see the Lozan's diagram, which will help you to remember the formulas for Gauss forward interpolation formula or backward interpolation formula. So are you familiar to this diagram? This diagram will simply help you to remember the formulas of Newton backward, forward, Gauss forward, backward, then Stirling's, then Bessel's. All these different formulas you can just remember using the Lozan's diagram. So are you familiar to this diagram? So here what we do actually is, suppose you have to calculate the value at at x naught. Okay, so corresponding to that, just write y naught. Okay, in the y column. Then all the preceding elements will be from x naught. It will be x minus 1. Just write it x minus 1, x minus 2, and elements after that will be x1, x2, and x3. Similarly, for y naught, here it will be y minus 1, y minus 2, here it will be y1, y2, and y3. Okay. Now, just write in between these terms, write 1. Okay. So, using that Lozan's diagram, you can simply remember the Gauss forward difference formula. So, for that, first calculate the difference table as we did in the previous cases. Just write x, f of x, then find the first divided difference column, second divided difference column, third divided difference column, and fourth divided difference column. Okay. Here you have to calculate the value of f at 1.55. Okay. So it is near this 1.5. So take x naught as 1.5. So if x naught is 1.5, then x minus 1 will be 1.25, x minus 2 will be 1, x1 will be 1.75, and x2 will be 0. Fine. Now calculate p. So how we will get p? It will be x minus x naught by h. So what is x that you have to calculate? 1.55 minus x naught, that is 1.5, and divided by h, that is difference. So here difference is 0.25, so divided by 0.25, so you'll get 0.2. Okay. Now I I hope you have got the first difference table. Now simply substitute the values of p and forward difference difference terms in the formula of Gauss forward difference formula. If you have any doubt in the formula or any of the steps, tell me and check, are you getting f of 1.55 as 0.4382? Is it clear? Are you getting f of 1.55 as 0.438? Okay. So this is the Lawson's diagram using which you can simply remember the formula. So for Gauss forward interpolation formula, you will use this line. Okay. So here just arrange the x column x and y. Now put the in between the consecutive terms in y, just substitute 1, put here 1 at every place. Now corresponding to y naught, write nc1. Okay, so now just place above that. Now this is the first divided difference column, so if it is y naught, then this will be del minus 1, this y minus 1, and this will be del y naught, this will be del y1, this will be del y naught, y2. Similarly here del y minus 2. Now just substitute here nc1, and above that just write n plus 1 c1 and n plus 2 c1. Similarly below that n minus 1 c1, n minus 2 c1, and n minus 3 c1. Similarly do for second and third and fourth column. Okay. Now for the Gauss forward interpolation formula, you will follow this path given by this circles. Okay. So it will be y naught plus, if we are going downwards, so write the element above that, that is nc1 into del y naught, plus, now we are going here, that is del square y minus 1. So you have to write the element below that. When you will go upwards, then you have to write the element below that. So you will get nc2. Okay. Now next term is del cube y minus 1. So as we are going downwards, so you have to multiply it with the element above that, that is n plus 1 c3. Okay. So in this manner you will get the formula for Gauss forward interpolation formula. Similarly for backward, and this curve is for Bezels and this is for Stirling's. Okay. And see, for Stirling it is like this, given by arrows. So for whenever there will be arrow, so you will be going in the straight way. Okay. So when you follow the straight path, you have to write the mean of the element above that and element below that. Okay. So here first value will be y naught into element above that is 1 and element below that is 1. So 1 plus 1 by 2. Okay. So you will give this will give you first term. Similarly for second term, third term, and fourth term. Okay, I hope it is clear. Stirling interpolation formula and Bezels interpolation formula. So let's move to the question. So next question is the solution of f of x at x is equals to 3.75 using Bezels formula is. So use the Bezels formula and find the value of f of x at x is equals to 3.75. Okay, you have been given this data. Use Bessel's formula and calculate the value of f of x at x is equal to 3.75. And tell me what you are getting. So which option you are getting? Is it A, B, C or D? Just use the Bessel's formula and substitute all the values at x is equals to 3.75. See what you are getting.
Nineteen point four.
Okay. So
19.47.
yes, it's correct. The value is 19.4074. Okay. So we'll proceed in a similar way. First, find the difference table. So for write the x values, y values, then find the first divided difference, second divided difference, third divided difference, fourth divided difference, and fifth divided difference. Okay. After that, calculate the value of p. Okay. So it will be x minus x naught divided by h. Here h is what? Difference between the consecutive terms, that is 3.0 minus 2.5, that is 0.5. So this will give you 0.5. Fine. Now calculate the value of y of 3.75 using Bessel's equation, Bessel's formula. So just substitute all the values x0, x1, x2, x3, x4 and x5 and the corresponding differences in the Bessel's formula and check, are you getting 19.4074? If there is any doubt regarding formula and anything, so tell me. Are you getting 9.4074? If it is clear, so shall we move to the next question? So question number 9 is, given the following data, you have been given the data and the value of y of 8 by using Gauss forward interpolation formula. So use the following data and find the value of y of 8 by using Gauss backward interpolation formula. That is, at x is equals to 8, you have to calculate the value of y. Okay, here you have been given x0 as 0, x1 as 5, x2 as 10, x3 as 15, x4 as 20, x5 as 25. And corresponding to that, you have y0 as 7, y1 is 11, y2 is 14, y3 is 18, y4 is 24, and y5 is 32. Okay, so now calculate the value of y at x is equals to 8. Is it 11.216, 12.513, 12.769, or 13.071? And calculate using Gauss backward interpolation formula. Okay.
11.216.
Just please check it. So 12.76. You have to use the Gauss backward interpolation formula. Here we have to calculate the y value at x is equals to 8. Okay, so it is near this point. So take it as x naught is equals to 10. So x minus 1 will be 5 and x minus 2 will be 0. x1 will be 15, x2 will be 20, and x3 will be 25. Okay, now x is 8. Here the difference between the consecutive terms is 5. So h is equals to 5. Now calculate p. It is x minus x naught by h. That is 8 minus 10 by 5. So you'll get minus 0.4. Okay. Now find the difference table. So arrange the values in the column x and y, and corresponding to that find the first, second, third, fourth, and fifth divided difference. Sorry, it should be second, third, fourth, and fifth. Okay. Now once you have calculated a difference table, just put the values in the backward difference formula, Gauss backward difference formula, and find the value at y at 8. Check your calculation. If you have any doubt, then tell me. You should get y of 8 as 12.769. Is it clear? Is there any doubt? Is it clear? Shall we move to the next question? Do you have any doubt? So next question is the solution of f of x at x is equals to 0.2 using Stirling's formula is. So you have been given data points. Okay, that is the value of y at x is equals -2, -1, 0, 1 and 2, and you have to calculate the value of f of x at x is equals to 0.2 using Stirling's formula. Okay, so calculate it and find it. Is it 0.3107, 0.3187, 0.3201 or 0.325? Just use the Stirling's formula, find the difference table and find the value of p and then use Stirling's formula. Calculate it. Calculate the value of f of x at x is equal to 0.2 using Stirling's formula. So what you're getting, you got the value of f of x at x is equal to 0.2. So the answer is D, 0.325. Okay. So here again you have to calculate the difference table. Just arrange the values of x, y and find the first, second, third and fourth divided differences and use the Stirling's formula. So here x naught will be, since here x is equal to 0.2, so take x naught as 0. Okay, so this will be x minus 1, this will be x minus 2, this will be x1 and this will be x2. Okay, and corresponding to that, this will be y naught, y minus 1, y minus 2, y1 and y2. Okay, so substitute all the values in the Stirling's formula. So first is y naught plus p, that is you have to calculate the p by x minus x naught divided by h. Here h is 1 and x naught is 0, so you will get p as 0.2 and then calculate the n coefficients using the Lorentz diagram, or if you remember the Stirling's formula, just substitute all the values, you will get y of 0.2 as 0.325. Okay, just try it. Are you getting it? If you have any doubt regarding formula or any of the values, just tell me. So everyone, are you getting option D? Is it clear? If you have any doubt, tell me in any of the questions or any of the formula. So are you getting y of 0.2 as 0.325? Is there any doubt? I hope it's clear. So this were the 10 questions that we discussed in the session of week 5. Okay. So if you have any doubt in any of the questions or any formula that we used, so you can discuss now. Or if you want to explain me any of the questions. Is everything clear to you? Or do you need me to move to any of the question again? Have you all got all the 10 questions? Solution of all the 10 questions? Or if it is clear, then tell me. Okay. So I hope this session helped you all. So thank you for joining week 5 session, and we will meet in the next session, that is week 6 session. Okay. So if you have no doubts, so we can end up with this meeting. Thank you all for joining. Thank you.
Thank
Thank you. Thank you.